So the first thing I want to do is I just want to quickly review graphing lines. Okay, so lines are going to be in, at this point, three forms. They can be in y equals mx plus b to graph easily. They can be in the yo or the vux form where we only have one variable. Those are our special case lines. So for this one, y equals 4x minus 2, negative 2, 0. So negative 2, 0. This is my y-intercept. Right? And we can even link a little bit to what we did with inequality. Since this is an equal sign, I know I'm going to use solid, and I'm also still going to use a solid line. So just because there's not an inequality, the rules are still the same about the equal sign. My slope in this case is 4 over 1. So from this first key point, I'm going to count up 4. 1, 2, 3, 4 over 1. And then I can go ahead and make my line. Okay, pretty simple. For the next problem, again, I have a y and an x. So in my head, I should be thinking y equals mx plus b, but there is no b written. So I'm going to add the plus 0 to the end. And then I'm going to start with that as my first key point, 0, 0. From there, negative 2 over 3, I'm going to count down 2 over 3. Okay. Connect those with a solid line again. This is solid. All right, so this is a solid line, and I'm done. Right? So even though it may not initially look the same because there are two variables, I want to use the slanted line formula of y equals mx plus b. We're going to come back to these examples because I'm going to show you how we can write them similar to absolute values so the rules are exactly the same. Okay? So for today, the absolute value function form is the following. Okay? This is the big idea here. It's going to be y equals, there's going to be an a, absolute value, x minus h, plus k. Now I know there are some of you who have taken this course before, or you've seen this formula before. And I think when we look at y equals mx plus b and we look at this, you can start to feel overwhelmed because there's so many new letters. But the good news is that a lot of the letters, what we do with them in terms of graphing is the same. Okay, so for me, excuse me 1 second, please. So the vertex, okay, so like if you remember when we graph lines, the vertex always started at the y-intercept. Our vertex for this is going to be located at h, comma, k, where the k is exactly the same and the h is going to be the opposite of whatever is written there. Okay, h, comma, k. All right, how we find the vertex, so the vertex is simply the starting point. Okay. So this is the shape of absolute value. This is what we mean by the vertex. This is going to be our starting point right there. Okay, I'm going to describe how to find the vertex right now. The steps to graph these, which is going to be our first skill today, is simply to plot the vertex, and then we're going to use the slope to count to find 2 more points. Okay. So this is what we're doing. This is the wording of it all. Okay. First of all, the basic graph for absolute value is y is equal to the absolute value of x. Now I'm going to write this out a little bit different. Y is equal to the number 1, absolute value of x plus 0 plus 0. So just like the problem up here where I filled in zeros for the variables that I didn't have, I'm going to do the same thing here. Okay? I'm also going to take a second just so that as we work through these notes, we can refer back to this formula at all times. Okay? So step 1, according to here, is to plot the vertex. So the opposite of 0 is 0. This remains the same. So this is going to be my vertex, 0, 0, starts here. Oh, you can't see that. Hold on. There we go. It starts at 0, 0. Now my slope, okay, I'm going to switch colors and use green, is going to be 1. Right? So now I'm going to zoom in a little bit on this one so we can see this a little better. So if my slope is 1, right here, I'm going to count up 1 over 1. But then if you remember, absolute value is a v. So I want to do a mirror image on the other side as well. These are the 2 additional points that I used slope to find. So this is going to tell me the first one directly by counting, but then I need to find the mirror image on the other side. Connect to make my v. Let's take a look at example 2. So I'm going to take what I have here and I'm going to write it out in this full form so I can answer the questions. So this to me looks like y equals the number 1, x plus 3 plus 0. Right? It may seem odd to you to add all these extra numbers, but what it does is it makes the process of graphing exactly the same for every single problem. So if I look here, my vertex is going to be located at the opposite. What's in here is the opposite of 3, which is negative 3, but the number at the end remains exactly the same. So over here I'm going to go to negative 3, put a dot. My slope, again, is 1. So from here I'm going to count up 1 over 1. But I need the mirror image on the other side. And then I can draw my picture. Okay? Now, one thing to notice, since x is on the inside with the plus 3, when this says plus 3, we know we're taking the opposite. So this graph, we would say, was shifted left 3 units. Okay? It looks like it should have gone right, but we always use the opposite from inside of the absolute value with x. So it shifted left 3. Right? Let's take a look at the U2B section here. If I write this out, I should be seeing 1, my vertex is going to be located at not negative 4, but positive 4, 0, 1, 2, 3, 4. My slope is again 1, so I'm going to count up 1 over 1. Those are my 2 subsequent points, and then I graph my v. All right. If you had to describe what happened to this, the parent function would start at 0, 0. But because now I have a minus 4 in here, I would say that this was shifted right 4. Okay, so I'm using words to describe the shift of the graph. All right, let's do another one. Right here. Okay, again, I'm going to write this all out so it looks exactly like all of the rest. Negative 1 is in front, x plus 0 plus 0. So you might wonder, well, why are you using zeros, but here you're using 1? Whenever we're multiplying, we substitute the 1. Whenever we're adding and subtracting, we substitute the 0. Okay, so my vertex now, following my procedure, is at 0, 0. Right here is my key vertex. My slope that I'm using to find the other points is negative 1. So from here, I'm going to go There's my slope there, -1/1. I'm going to go down 1/1. Right? But now think about this. The V normally opens up. Now it's opening down. So now I need to have the mirror image point on the other side here. Okay, for absolute value, it will either open up or it will open down. If the A in front is negative, then it's going to open down, and my mirror image is created this way. Okay. Example 4, y equals 1, x plus 0 plus 3. My vertex is located at same exact, 0 doesn't have a sign flip, so it says 0, but my k doesn't switch signs, it's on the outside, it's still going to be a +3. So 0 plus 3 is right here. Key vertex. My slope is 1. So this means it opens up 1/1, up 1/1. And I can draw my V. Okay, let's try one more. Y equals -1, x plus 0 minus 3. Vertex, this is the opposite of 0, which is 0. -3 stays the same. Big dot for the vertex. My slope is -1. So I'm going to go down 1/1, which also shows me my V opens downward. Mirror image here. Draw. All right, a couple more of graphing. Y equals all of this. Okay, what I'm going to do is I'm going to put the 1 in front. Now it looks like the form that it always is. My vertex is going to be located at not +2, but since it's coming from inside of here, becomes -2. The number on the outside stays the same. So I'm going to go to -2, 3. My slope is 1. So I'm going to go up 1/1, up 1/1 mirror image, and I'm done. Now, I just want to talk verbally real quickly. If I were to describe what happened here, my graph shifted left 2 and up 3. Left 2, up 3. This graph, the home graph, should be at 0, 0. Okay, moving to the next example, I'm going to put a 1 in front. My vertex is going to be at the opposite of -1, which is 1. -2 stays the same. So I'm going to go right 1, down 2. This is my vertex. Down 1/1, down 1/1. It opens downward. The slope was -1. Draw my V. Now my last two examples that I want to go over. The first one is going to involve me writing this out to look like every other absolute value. Y equals 1/2, x plus 0 plus 0. Vertex, 0, 0. Slope, 1/2. Up 1/2. Don't forget mirror image, up 1, back 2. And now when I draw this, it is significantly wider. Right? My graph didn't shift at all. I just had a change in the slope. Last one, y equals, my vertex is going to be located at -1, +1. Don't forget, opposite stays the same. My slope, however, is -4/1. So I'm going to count from this point, down 4, 1, 2, 3, 4/1. This is a V that opens downward. Down 4, left 1. So I get that upside down V look. And I'm done.